Hi students, in this lecture we are discussing about hexadecimal number system. The base or radix of hexadecimal number system is 16. So there are 16 different symbols or digits to form the numbers in this hexadecimal number system. And these numbers ranges from 0 to 15. So we can look how these numbers are arranged. On the right side, I have written the decimal numbers. On the left side, it's equivalent hexadecimal numbers. So 0 to 9, same for both hex and decimal number system. 0 up to 9. Then 10 in the decimal number system is written as A, capital letter A in the hexadecimal number system. 11 is represented as B, 12 is represented as C, 13 as D, 14 as E, and finally 15 as F. So F in hexadecimal number system means the 15 in the decimal number system. So 0 to F. These are the different symbols available with the hexadecimal number system. Instead of 10, we are using A. Similarly, up to F. Then again, hexadecimal number system is a weighted or positional number system, just like binary, decimal, and octal number system. Each digit has its value expressed in powers of 16. Starting from this point, when we move towards left, the powers are increasing. That is 16 raised to 0, 16 raised to 1, 16 square, 16 cube, and so on. If you are proceeding towards the right, the powers are decreasing. That is 16 raised to minus 1, which means 1 by 16. Then 16 raised to minus 2, that means 1 by 16 square. Then 16 raised to minus 3, and so on. Next, we will see about how we can convert a hexadecimal number to its equivalent decimal number. The same technique which we are used for binary and octal numbers, but only the difference is that here we are using the powers of 16. So consider the number 27FB. First, we have to convert this F and B to its equivalent numbers. That is, I am taking the rightmost bit B. B into 16 raised to 0 plus F into 16 raised to 1 plus 7 into 16 square plus 2 into 16 cube. Next, we can simplify. B is equal to 11. Since A is equal to 10, B is 11. So, B can be replaced with the digit 11, with the number 11. So, 11 into 16 raised to 0 plus the letter F is replaced with the number 15. 15 into 16 raised to 1 plus 7 into 16 square, that is 7 into 2, 56 plus 2 into 16 cube, 2 into 4096. Upon simplification, we will get as 11 plus 240 plus 1792 plus 8192. When we add these four numbers, we will get the result as 10,235 to the base 10. Okay, 10,235. So the decimal number 27FB is equivalent to this number in the decimal number system. Then hexadecimal fraction to decimal. How we can convert hexadecimal numbers with the fraction to decimal number system. Again, I am taking the number 3E4FC, 3E.4FC to the base 16. First, we have to replace each number with the equivalent values. 3 same as 3. E can be written as 14. Not a separate digit 1 and 4, but take it together 14. Then the hexadecimal point 4. 4 is the same as 4. Then F, its equivalent is 15. C is equivalent to 12. A for 10, B for 11, and C for 12. So, next step is to assign powers. E is the first symbol on the left side of the decimal point. Hexadecimal point. So, E, that is 14, need to be multiplied with 16 raised to 0. 14 into 16 raised to 0 plus 3 into 16 raised to 1. We are moving in this direction. e into 16 raised to 0 plus 3 into 16 raised to 1 plus, then we are considering the numbers on the right hand side. So 4 into 16 raised to minus 1 plus f, that is 15 into 16 raised to minus 2 plus 12 into 16 raised to minus 3. On simplification, we will get the expression like this: 3 into 16, 48, 14 into 1, that is 14, 4 into 16 raised to minus 1, that is 4 by 16, that is 0.25 plus 15 by 16 square, which evaluates to 0.0585 plus 12 by 16 cube, which is equal to 0.0029. You can use the calculator to solve this type of problem. Then if we add these 5 terms together, we will get the result as 62.311523 to the base 10. With this, we have studied about binary, octal, decimal and hexadecimal number system. And we have also learned how we can convert these numbers to decimal, how we can find out the decimal equivalent of the numbers in different number system, that is binary to decimal, octal to decimal, and finally hexadecimal to decimal conversion. The rule is same. We have to multiply the digits with the corresponding powers. The powers of 2 are used if you are converting from binary numbers. The powers of 8 are used if you are converting from octal to decimal, and the powers of 16 are used if you are converting from hexadecimal to decimal number system. Thank you.